Okay, good afternoon all.
Good afternoon, sir.
I hope the screen is visible.
Yes, sir.
Okay. Okay, we were discussing about the uh, few new concepts, as in they are not new for you, but from the dynamics and from the uh, equation of dynamic equilibrium point of view, this will be kind of new. Now see, we have discussed about the work energy equation, isn't it? So resultant work done is equal to change in the kinetic energy. This is what we have studied. Resultant work done can be represented by RW. Okay, RW equal to W by 2G uh, final velocity minus initial velocity square. This is what we have studied. First thing. Second thing, we have seen the impulse momentum equation, which is given by R into T is equal to mass into V minus V naught, you can say, change in the momentum. That is what we have seen. We have also discussed about the law of conservation of momentum. That is final momentum is equal to initial momentum, right? And with respect to that, now we will see the next part, that is the collision. Collision. Collision is nothing but abrupt, short duration encounter between two rigid bodies or bodies, those are in succession. Okay, it is short, abrupt, short duration encounter between two bodies or the bodies are in succession. Right. In our syllabus, we are learning. We will be learning only such type of collision, typical collision cases. Okay. So let's say there are two rigid bodies, they are getting collided with each other. Uh, this line, which whatever I have drawn, this is known as line of impact. Line of impact. That means these two bodies will come in contact with each other in such a way that there will be an impact. Okay, impact is nothing but this term, right? Uh, there are few associated terms for this case. For example, the arrows which I am showing, these are nothing but the velocities with which these two rigid bodies are moving. So let me say this is velocity of this rigid body A and this is the velocity for the rigid body B. If such is the case, in which you will find that the velocity of the rigid body of A and B, or the two colliding rigid bodies velocities, if they are in the line of impact, in the direction of line of impact, then such kind of impact is known as direct central impact. This is known as direct central impact. Okay. Then there is another term which is known as oblique impact or indirect impact. In such case, where there is an oblique type of impact, what actually happens is, so again these two rigid bodies, AB, this is the line of impact. Okay, this is the line of impact. If the velocities are not along the line of impact, those are known as your indirect central impact or oblique impact. Okay, so this is VA, BB, right? There may be a possibility that the velocities are in different direction. They are not exactly on the line of impact. So such kind of impacts are known as oblique type of impact, right? Uh, Now we need to understand few terms which are involved whenever two bodies they collide with each other. What happens when these two bodies they are in contact with each other because of that, because of the associated velocities? What will happen? The first of all, just after the impact, just after these two rigid bodies come in contact with each other, because of the elastic property, every body has some or other elastic property associated to it. What will happen? There will be a point at which these two rigid bodies may get separated. Okay, so there are two cases. First is because of these velocities, they will come in contact with each other. That duration is very small. Okay, because it is an impact, right? And as per the definition of impact, it is nothing but the small amount of duration for which the two bodies are getting collided. So it is the duration which is very small. Because of that impact, you will find there will be deformation. Okay, there will be deformation, and this deformation is very less, or rather you can say this deformation is for less duration. This is known as deformation period or period of deformation. Very small duration, and after some time, after the deformation has taken place because of the elastic properties of these rigid bodies, these two rigid bodies will try to get separate away from each other, get move away from the away from each other. So this duration is known as restitution. Restitution. Okay. So these two terminologies are essential for our understanding purpose, and based on uh, our syllabus is restricted only for the line of impact, and that too central type of impact. Okay. So because of that, let's say, for example, there are two rigid bodies like this. One minute. Okay. Something of this sort. One has got less mass, let me say M1. Another has got higher mass of M2, and the associated velocities are something of this sort. Okay. So this particular mass is moving towards this, but this is also moving. So let me say V1, V2. These are the initial velocities because of which they are you can say M1 is approaching towards M2, and if V1 is greater than V2, so what will be the case? This will collide, and what will happen after collision? After collision, this case will occur. This will be again mass M1 and mass M2. These masses won't change, but certainly there will be change in the velocities. And what I will say, let V1 dash be the final velocity after collision, V2 dash after separation, not after collision, after separation. So this is stage 1, you can say. Over here in stage 2, there is a collision. Okay? And this is stage 3, wherein the two rigid bodies are separated. Okay? And after separation, they will move with different velocities, V1 dash and V2 dash. Okay? So you can say, you can term this as before impact, before impact or collision. Okay. Second stage is where you will find that these two bodies are in contact with each other. And third is separation, or you can say this is the case after impact. Based on this, the formulation, if we want to formalize this situation, the formula related to this, particular, particularly talking with respect to these two terms, okay, that is known as coefficient of restitution, and it is denoted by small e, where you will find that if you assess this situation and if you want to represent it into some formulation, then you will find that this coefficient of restitution is nothing but a ratio which is speaking about the relative velocity of separation to relative velocity of approach. Relative velocity of separation to relative velocity of approach. Okay, and mathematically it can be expressed as uh, keeping in mind this situation only. This is true for this case only, and then you can apply this case for any other situation. So what it says, it is minus of V2 dash minus V1 dash divided by V2 minus V1. So if you can see, these are the initial velocities, you can say, and this is final velocity for mass 2 and final velocity for mass 1. Okay. So this is the generalized equation for identifying the coefficient of restitution. This is known as coefficient of restitution. If a body is, or rather if E value comes out to be 1, let's say, based on the ratio, if it comes out to be 1, it says that if E is equal to 1, then it is known as perfectly elastic body. Perfect elastic body. And if E is equal to 0, it is known as perfect plastic body. So nothing is perfect actually, neither elastic nor plastic. It is somewhere in between 0 and 1. The value of coefficient of restitution for different materials, you will find that it will be between 0 and 1. It won't be perfectly elastic, nor it will be perfectly plastic. This is a hypothetical situation, you can say, right? So, if E is equal to 0, what do you expect? That after collision, these two bodies, will stick to each other. It will get clinged, isn't it? They will get clinged together, and there won't be any kind of separation. In first case, what will be the interpretation? Since the magnitude of relative velocity after impact will be same as that before impact, it will be same. Okay, that is final and initial velocities will be same, right? So with this understanding, because this equation will be helpful for us to understand sorry, the unknown parameter, whatever we will be identifying, right? So let us try to make use of these formulations, you can say, in our numerical. Let us try to solve this numerical. Right. So there is a situation wherein such then there is another ball like this. And then it will move like this. Okay. Things over here, the given conditions are, these are two balls A and B. Ball A has a weight of 150 Newton. Ball B has a weight of 100 Newton. This dimension is 1.8 meter. This is angle theta. This is 60 degree given. Okay. What is given? The balls A and B are attached to stiff rod of negligible weight. Ball A is released from the rest and allowed to strike ball B. The coefficient of restitution, that is small e, is 0.6. This is given. Determine the maximum angle theta through which the ball B will swing. Okay, and what is the maximum and minimum tension in the rod attached to B? Tension, minimum, maximum for this, for ball B, that you are supposed to find out. You are supposed to find out theta. And one more thing, if the impact lasts for 0.01 second, find the average impact force. Okay, so there is one more situation. The duration of impact is given t, it is 0.01 second. This is given, right? So let's go step by step and let us try to make use of all the equations which we have gone through, we have seen, and let us try to apply the same for this case. So as you know, this is the situation. Let us try to first of all identify the velocities which are responsible for formulation. So let's say, let us find out first of all the velocity, final velocity, because see initial position पे ये है, finally it will reach over here. That ball A will start from this location, it will come to this point, and it will strike ball B, which was at rest initially. So the velocity of this A will now become the velocity of ball B, and because of that it will move at this location, which is this point where you will find the velocity of B will be 0. Final velocity of B will be 0 at this point. So let's go step by step. First of all, let us apply work energy equation. Okay, as per work energy equation, the resultant work done is equal to change in kinetic energy. You can express it like this. Okay. So what is the work done? Work done by the ball A. How much it should be? Can anyone tell me? What will be the work done value? Yes, force into displacement, isn't it? So how much is the force value associated to ball A? How much is the force value? Yes. So this is 150 Newton. Great. Okay. This is 150 Newton. Am I right? This is given. Okay. And this 150 Newton will traverse this much distance. Okay. This much distance in the sense इतना portion वो cover करेगा. How much is this portion? Yes. How much is this value? Please let me know. See this ball, it starts from this point and it covers this much distance. So vertical distance it is covering, right? Am I right? ये ऐसा situation है. ये point तक वो पहुंच रहा है. ठीक है. So you are supposed to identify this much distance. कितना रहेगा ये? This is 2.4 meter. This is 60 degree. How much should be this much value? Yes. Are you people there?
Yes, sir.
Good. So how much should be this much value? ये अगर 2.4 meter है, this is 60 degree. Okay. I have dropped a perpendicular over here. You can find out this value. देखो ये total, this will be again 2.4. कितना आ रहा है? how much? What is this value? Let me call this as HA. ये कितनी वैल्यू है? This is if it is HA, this will be 2.4 minus 2.4 cos 60. Am I right? By that, I think you will get 1.2 meter HA. Okay. So the resultant work done, it will be what you can say weight A into HA. Now just let me know whether this work done is positive or negative. What do you think? इतना बता दो यार. Yes, what it should be. Yes. What will be the work done? Whether it will be positive or negative for this case. See, this is HA. This portion. Okay, and your weight is acting in the downward direction. And as you can see, with respect to this weight, the displacement is again in the downward direction. Therefore, this work done will be positive work done. Then W divided by 2 into G. Okay. Okay. So final velocity VS, what I can say VA dash square minus VA square. So let me consider final velocity to be VA dash and final velocity of B to be VB dash. Initial velocity VA and VB, like that. Let us assume that. Or instead of this, what you can do is, instead of dash, you can say final velocity, you represent it by V, and initial velocity you represented by small u. ठीक है, ये आइडेंटिफिकेशन रखेंगे डैश का जनरेटिव गुना. So final velocity va square and initial velocity ua square. So if you notice, for this situation, for ball A, the initial velocity is 0. We will identify the final velocity. We will substitute the relevant terms. Weight into distance is 1.2. 150 divided by 2 into 9.81 into VA square. This is unknown, whereas this U is 0. And therefore, I will get some value for VA. VA is the final velocity of the ball A when it will reach up to this position. Because over here you will find that there is an impact. Okay. So what value of VA do we get? I am getting it to be 4.85 meter per second. You can verify. Then what will happen? After gaining this velocity, it will collide with ball B. So there is a collision. Second step is collision. Collision of A with B. We know, as per the principle of, or the law of conservation of momentum, law of conservation of momentum. Initial momentum is equal to final momentum. So according to that, WA into initial UA plus WB into UB is equal to final WA into VA plus WB into VB. Okay, you substitute the values. As you can see, WA is 150 into, right. So because of the collision, what will happen? This final velocity of VA will now become initial velocity of uh, ball A, isn't it? So over here, this is 4.85 plus WB. WB is 100. What, what is the initial velocity of ball B right now? At the point when ball A is getting collided with ball B, it is 0, isn't it? Am I right? At this situation, when there is collision, final velocity of ball A is actually 0. Sorry, is unknown. Final velocity is unknown. So this will be 150 into VA. And similarly, after collision, this will move over here. So final velocity of ball B is again unknown. So it will be VB. So this will give me one equation which will have these terms. 150 VA plus 100 VB is equal to, how much is this value? How much is this value? Please calculate and substitute over here. Okay? This is, let's say, equation 1. This is during collision. Okay? Then we have information related to coefficient of restitution. As per the formula, coefficient of restitution is, you can say, velocity of B minus, this is final velocity, divided by initial velocity. Okay? These are final velocities. As per the given information, this is 0.6 minus VB. Make sure that this minus sign should be there in the equation if it is like this. Okay? VB final velocities, these are to be calculated. You know, initial velocity during collision, what are they? Initial velocities are same. For ball B it is 0, for ball A you have found out it to be 4.85, and therefore you will get one equation in terms of VA and VB, and I am getting that value to be like this: VB minus VA equal to 2.91. 2.91. This is second equation. You please verify, are you getting the same equation or not? Please check. Please check this. Is this okay? And if you solve these two equations, you will get VA and VB values. So as per my calculations, VA comes out to be 1.75 meter per second. VB I am getting it to be 4.66 meter per second. And I am getting both the values to be positive. Okay? So these are the final velocities associated to the balls A and B. Okay? Now to find the angle theta through which the ball B will swing, that's what we need to find out first of all. So the initial velocity for ball B is nothing but now the final velocity whatever we have calculated, isn't it? Now over here, in order to calculate this theta angle, the initial velocity of ball B will be nothing but the final velocity whatever you have calculated over here. And the final velocity for ball B, when it will reach over here at this point, it will be 0. Correct? So again, you can apply work energy equation. So this is third step, you can say. Third step, work energy equation after impact. Okay. So for this situation, what you can say that the initial velocity of B will be nothing but this final velocity whatever you have obtained from this equation. So that will be UB. It is 4.66 meter per second. Therefore, now ये देखो सिचुएशन अभी कैसे चेंज हो रही है. This is the weight, and this weight has moved up to this point after collision, right? It has moved at this point. Now you are supposed to identify this height. Let me say height B. What will be the value of height B? Height B will be this is 1.8 minus 1.8 cos theta, because this is theta angle, this is unknown, cos theta. बराबर है? This HB, this much distance, will be 1.8 minus 1.8 cos theta value. This much. True. Now let me know what will be the work done, positive or negative. What do you think? What will be the work done, whether it will be positive or negative? Here you will see that this will be negative. Reason? You can see the force is acting in the downward direction, but the displacement at this point is upwards. Can you see that?
Yes, sir.
Actually, it was over here at this location, but it has moved over here. The movement of this ball from this point to this point with respect to this is upwards, but the force is acting in the downward direction. Therefore, it will be negative work done. In earlier case, if you have observed, the position of ball A was here, and it has moved from this point to this point. Displacement is again in the downward direction, and the weight or the force, whatever is acting, it is again in the downward direction, and therefore it was positive work done. Whereas over here, it is exactly opposite. I hope you have understood this thing. So it will be WB into HB, negative sign because it is a negative work done. WB divided by 2G into final velocity VB square minus UB square. UB square. So we know the final velocity is 0 at this point for ball B. Correct? So I will substitute the values. HB is 1.8 minus 1.8 cos theta is equal to 100 divided by 2 into 9.81 into VB square. It is 0 minus UB square is 4.66. Rather, UB is 4.66 square. From this, we will certainly get the value of theta. Okay? I am getting theta value as 67.35 degree. This is what I am getting. You can please check. Theta 67.35 degree. Okay. Next is what is asked that you are supposed to calculate the impact force. Impact force if the impact lasts for 0.01 second. So if this impact it lasts for 0.01 second, what will be the average impact force? So for that, to identify the impact, we have the impulse momentum equation. Okay, so the resultant force into T is equal to mass into final velocity minus the initial velocity, and this will certainly be with respect to the ball B. So we know uh, this resultant force, which is nothing but the impact force, will be unknown, into 0.01 second. Mass B, or it can be converted as 100 by 9.81 divided into what will be the final velocity? Final velocity, it will be now 4.66 this term. Okay, this is after impact. Okay, but during impact, this was the final velocity, if you remember. Whereas the initial velocity during impact was 0. Okay, and from here you can calculate the what you can say, the impact force. I am getting impact value to be 4750 4750.25 Newton. You can verify this, right? So the remaining part is to identify the tension, minimum and maximum tension for this ball B. That I will be discussing in the next class. I hope you have understood this thing. In this numerical, I have tried to cover all the equations which we have learned. It is not necessary that in one numerical itself we will get everything. You may get different numerical examples wherein different situations are to be applied. So somewhere you will have to apply only work energy equation. Somewhere the coefficient of restitution equation along with the conservation of momentum equation can be used. Okay, so it will completely depend upon the nature or the type of the numerical which will be asked. Okay, so we will discuss the calculation of T minimum maximum for ball B in the next class. Okay, so I will stop here. You people can leave.
Thank you, sir. Thank you, sir.